Alright, nerds, so today we're going to look at evaporation and crystallization as ways of separating out a solute from a solvent. Boom, let's go. Alright, so what's the point? Basically, we're going to define crystallization and evaporation as separation techniques. We're going to explain the relationship between those two, and we're going to identify the physical property being used. Now, if we have a look over here, this is industrial evaporation. This is evaporation of salt water to collect the salt, and this is in India, and this happens across the world. Alright, so evaporation, what is it? Well, it's basically we use it to separate solutes, solid solutes, from solvents by evaporating off the solvent, and it leaves the solute alone. Okay, so the solvent is evaporated off into the atmosphere, or wherever, and the solute is what we're left with. So we use it in industry to collect salt, and there's a few other places it's used. Now, basically, it can be done fast with heat or slowly with cooler temperatures, more of an ambient temperature. Both of those work, and we're going to have a look at these in a couple of experiments to do. So it's important that you remember that the solvent evaporates, not the solution. So the solution doesn't disappear because the solute's still there. For the solution to disappear, you have to lose both of them, solute and the solvent. We only lose the solvent. The physical property is the solubility of the solvent. Now that sounds weird, but as more of the actually that should be solute, solubility of the solute. This is where we see who's listening or who's just pausing and writing stuff down. So change that to solute. So the solubility of the solute is what we talk about. So as the solvent disappears, the solute comes out of solution because it's not soluble enough to stay in there. All right. So the advantage of evaporation: nearly all solute are able to be collected, so we can nearly get all of it. It's slow, and you lose the solvent. Those are the disadvantages. So let's have a look at a quick way to do it. First, this is the way we would do it in the lab. You can evaporate with ambient temperature, but this is to do it fast. So you've got your evaporating basin here, solution in there, and we apply heat. And as we heat up, the solution, the solvent, evaporates off and leaves us with the crystals dissolved, the solute crystallized down below. So even in evaporation, we end up with crystals. Crystallization. This is the process here. We stir something in, stir in the solute with the solvent, we mix it up. All right, so then we have our evaporating basin and we heat it up. So most of the solution is evaporated, but not all of the solution will evaporate. So as it cools down, the solids will reappear down the bottom. They'll reform down there. So as it cools down, they won't be able to stay in solution, so they will crystallize down the bottom. We then, once it's cold, we pour off the solvent, and we're left with the crystal solute down the bottom. Now, essentially, it's the same as evaporation, but the process is different. There's an extra step. It's faster. It's much faster, but you recover less of the solvent. That's the solute. You recover less of the solute, and the solvent's still lost. All right, that's it. Those are the differences. Now, once again, you had to have been listening. Make sure that you realize that. Go forth and conquer, my friends.